Implement two stacks in one single array. In this video, I will show you how to implement two stacks in one single array. A stack is a data structure that is based on LIFO. LIFO means last in, first out, means the element pushed into the stack in the last will be popped out first. We can access the elements of the stack using top of the stack. Top function returns the top element of the stack. Okay, let's get started. Hello everyone, welcome to the channel. In this video, we are going to implement two stacks in one array. Here you can see on the screen we have two stacks. We have to implement it by using one single array. Here we have an array has maximum size 10, max equals 10. For implementation of two stack, we can divide the array into two equal halves so that we can put all the elements of both stacks. We can divide our array in such a manner such that stack 1 elements will be pushed from 0 to max divided by 2 minus 1. That is, here in this case 0 to 4, max is 10 and 10 divided by 2 will be 5, 5 minus 1, that is 4. Stack 2 elements will be from index 0 to 4, and stack 2 element will be from max divided by 2 to max minus 1, means max divided by 2 is 5 to 9. Okay, means our stack 1 will be from 0 to 4 and stack 2 will be from 5 to 9. Here we will push elements of the stack one by one, and hence in this way we can implement two stack. Okay, let me show you. Here suppose we push 1 in stack 1 and push 6 here in stack 2. It will be, our stack will grow from left to right, and here also stack 2 will also be grow from left to right. Okay, after that we will push 2, here we will push 7, here we will push 3, here 8, and here we will push 4. Here in stack 2 will have 9, and here we have 5, and in stack 2 we will push 11, 10. Okay, now our stack is full. Is full function returns 1, that is true. In this case means our stack is full, our stack don't have any space left. Okay, and if we have to pop out each element, we will pop one by one. If we pop from stack 1, we can pop one by one, 5, 4, 3, 2, 1, and we can pop in stack 2 also. We can perform each operation. Each operation means push, pop, top is empty, size, as we discussed in previous videos. Okay, but in this approach we have a problem. What is the problem? Let me tell you the actual problem. When we divide the both spaces, when we divide the array in equal spaces, then here let's take another example. Here we have an array that has max capacity 12, and stack 1 has from stack 1 will be implemented from 0 to 5 and stack 2 will be implemented from 6 to 11. Let me push the elements into this stack. Suppose we have pushed 1, 2 and 3, and here we will stack 2 from 6 to 11, and from 0 to 5 stack 1 will be implemented. Okay, and we will push 6 at 6 and 6th index, 7, 8, 9, 10, 11. Now our stack 2 is full. Is full will return true because our stack 2 is full. But our stack 1 has 3 spaces left. Okay, but if we have to push another element into stack 2, means if we have to push, suppose we have to push another element, that is 20 into the stack. Okay, we can't push another element into stack 2 because our stack 2 has full, it will return overflow. Okay, but here you can see in stack 1 we have 3 spaces left. These spaces will be wasted because we have spaces but we cannot use it. Okay, this is the actual problem with this equal half approach. Okay, यहाँ पे हमारे पास स्पेसेस बचे हुए हैं बट हम इनको यूज नहीं कर सकते. Okay, to solve this problem we have another approach for implementing two stack. You can see here we have max capacity 12 and this is t1 equal -1 and t2 equal max, means these are the indexes of two stacks. This is -1, t1 is the index, t1 is the top index, t1 shows the top index, top element of the array, t1 is the index of top element, and t2 is the index of top element of stack 2. T1 is the top index of stack 1 and T2 is the top index of stack 2. Okay, here in this case we will implement implement one stack from leftmost side. Here from here we will implement stack 1 and we don't have any boundation of size. We have total, we will use total max size, that is 12, and stack 2 will be implemented from here. First element will be pushed at 11th position and so on. It will grow from right to left, and stack 1 will be grow from left to right, and when they reach to one less than from another index, it will return each full. Okay, let me show you. The benefit of using this type of approach is we can use all the spaces, we can use each space, each block of array, and we can put each, we can use each element, we can use each spaces of array. Here 3 spaces were left in the end. In case where stack 1 has a different size, means stack 1 has different size and stack 2 has different, means we can say if stack 1 has 5 elements and stack 2 has only 2 elements, and we have to push another 2 elements into stack 1, we can do this by using this approach. Let me show you. If we push 1 in this stack, initially our T1, that is index of stack, top index of stack 1, it will be -1. If we push 1, we have implemented push 1 and push 2 for pushing the elements, and we have implemented pop 1, pop 2 for popping out the elements from stack 1 and stack 2 respectively, and isFull function that will return that our stack is full or not. isFull is common for both stacks. Okay, let me show you. First we will push 1, we call push 1, that is 1. We will push one element 1 into stack 1. It will be implemented like this, and T1 will be now 0. Okay, and we will push 10 at stack 2. It will be 10 will be here. Okay, and T2 will be now 11. At 11th place we can find the top element of stack 2. After that we will push 2 into stack 1 and 9 into stack 2, 3 into stack 1 and 8 into stack 2. Now we will push into stack 2 only, 7, 6, I am pushing in stack 2, 5, 4, 3. Now when we push the element into the stack, it will check that isFull return true or not. If isFull returns true, it will return overflow. Okay, let me check. Here T1 has 2, T1 has value 2 and T2 has value 4. Okay, T2 has value 4. Now let me check here. T1 plus 1, T1 plus 1 means 2 plus 1, that is 3. 3 is not equal to T2, T2 is 4. 3 is not equal to 4. We can push one element into the stack. Let me put 3 again, 3 here, we push 3. Now T2 is decremented as 3 and T1 is 2. If we check isFull, if we push another element, we have to check isFull, and when we call isFull, T1 plus 1, that is 2 plus 1, that is 3, 3 equals 2, isFull returns 1, that is true in this case, and it shows our stack is full. Okay, this is how we implement stack. In the pop, we will in the pop one we will decrement the top index, and in pop 2 we will increment the top 2 index. Means we are while we pushing the element, we are moving from right to left in stack 2, and popping, in case of pop, we will move from left to right in stack 2. Okay, let me show you, let me take you to my code editor and show you how we can implement it. Here I have written already the code. Here max size is 10, and the stack variables are t1 t2, that shows the top index of stack 1 and stack 2. Here we have functions push1, push2, pop1, pop2, top1, top2, is empty1, is empty2, is full. Here you can see is full is common for both of the stack, and size1 and size2. Let me show you the implementation. In push1, we will check is full. If is full returns true, the stack will overflow. And where is the is flow? Is flow, sorry, is flow, not, it is not is flow, it is full. Is full returns t plus 1 equals t2. If this condition is true, it will return true, that is 1. Otherwise it will this function returns 0. Okay, and in case of size 1, it will return the size of the stack 1, and size 2, it will return size of stack 2. And when t1 equals -1, is empty 1 function returns is empty, stack 2 stack 1 is empty, and is empty 2 returns is empty 2 checks whether stack 2 is empty or not. Okay, and same as in case of top 1 and top 2, it will return top of the stack of stack 1 and stack 2 respectively. Okay, in case of push 1, we will increment. Here I have used pre-increment. We increment first, after that we will put the element at that position. Okay, and in push 2, we will decrement first, after that we will put the data into it. Here you can see, by pushing one element in stack 2, we are moving from left to right. That is, in case of stack 1, we are incrementing the indexes, or indexes are incremented. Means first it was -1, it becomes 0, after that 1, after that 2, after that 3, after that 2. Stack 1 is from 0 to 2. Okay, and stack 2 is from 3 to 11. And here in this case we push 10. After pushing one element, it will, our index of top element, top index of stack 2 will be decremented by 1. Initially it was 12, now it is 11. After pushing another element, it will be 10. After that it will be 9. After that 8, 7, 6, and so on. It will, and then it will become 3. This is what I have done here. You can see push 1 and push 2. Okay, in case of pop, we will do same. In case of pop 1, we will decrement the indexes, and in pop 2 we will increment it. We have incremented the indexes of stack 2 because we are moving from left to right. Okay, here I have called, or we have pushed 1 2 3 1 2 3 11 and so on. I have called push 1 and push 2 after. Now it is showing the correct output. And in stack 1 we have 3, 2, 1, and in stack 3 we have 5, 13. We have 13 5 times, after that 12 and 11. You can see we have a total 10 elements, and when I have called push1 function with the value 100, it returns overflow. Okay, show you. You can see the stack is overflow. Okay, this is how we implement two stacks in one array. You can see by using both the approaches we can implement two stacks in one array. Okay, but I recommend you to use last one. Okay, it is efficient and we can efficiently use all the spaces of the array, and it is also easier to implement. Okay, hope you understand the concept of this video. If you understand the concept of the video, like my video, share with your friends, and thanks for watching. Happy coding.